Thank you very much, Greg, and thank you for this opportunity to talk about fall armyworm yet again. I have sort of focused very much on the current situation today. I know from the feedback that was provided as you registered that there's a broad range of questions that people have, and hopefully we can cover those that aren't covered in the question and answer session if I don't cover them in the presentation itself. But I think what we've been doing is sort of trying to address the critical issues as they arise, and currently I guess to some extent to our surprise, we find ourselves in a situation where winter cereals that were planted early, or I guess, typically early this year, have been quite heavily impacted. And I think that one of the major challenges is just a lack of awareness, because it's not an experience that we have had previously in the 4 seasons that fall armyworm has been active in Australia. So right up front, I wanted to put these key messages for those of you who are growing or reliant on or managing winter cereals, that it is absolutely critical that in this initial period that you're checking all winter cereals within 5 to 7 days of emergence. And that recommendation is around the rate of development that we expect, and it should hold you in pretty good stead to find an infestation before you get that sort of the impact that you can see there in that photograph. That's a paddock out on the inner downs at Clifton that I went out to yesterday, where there are very large bare patches that have appeared twice now with a resow, because the fall armyworm are there and established in that paddock. So it really is the medium and large larvae that will slow crop growth by defoliation and also have the capacity to kill plants. And one of the things that's really surprised me is just how vulnerable winter cereal seedlings are to the stem damage that's caused by these large larvae. And I'll talk a little bit more about that as we go along. Establishing grasses, ryegrass, Rhodes grass may also be at risk. We know that from North Queensland, Rhodes grass is vulnerable to fall armyworm during establishment. So at this point, that's sort of where we are. You can see that the reports to date have been damage to oats, wheat, barley and Rhodes grass. And then a little question about ryegrass, particularly where it's established in an oat ryegrass mix, and the presence of oats provides that opportunity for fall armyworm to develop to a damaging stage on the oats. And once those oats are denuded or removed from the pasture, they'd move on to whatever else is green, in which case the ryegrass is highly vulnerable. In terms of where we're seeing these impacts, I've had reports as far afield as through central Queensland and down into the mid-north coast of New South Wales. And I guess, I probably hear of a fraction of what's going on out there. But I would say that if you're in an area where there's been fall armyworm activity over summer and you're now planting winter cereals, that these issues apply to you. When it comes to pasture, there's been no investment in fall armyworm work in pasture, so we know very little about the impact or the potential impact of fall armyworm on other sown pasture species and on native grass species. Why are we seeing fall armyworm in winter cereals this year where we haven't seen it before? Well, I think it's most likely that we have had what has been the highest level of fall armyworm activity through summer that we've seen since fall armyworm arrived in 2020. It's not exactly clear, usually, I guess typically our understanding of what the drivers of outbreak years are, or higher pressure or low pressure, come with experience. And we haven't had very much experience with fall armyworm at this point. But what we know about caterpillar pests, things like Helicoverpa, the native armyworms and so on, is that abundant hosts, particularly both crop and non-crop hosts, availability of those, it's usually associated with wetter seasons, particularly wet and mild temperature winters are real drivers of early population growth. High humidity and temperature for fall armyworm, absolutely perfect. Fast development, which means more generations in the season, which means that by the time you get into the end of summer, your populations are very large indeed, which is exactly what our experience has been. The other thing that we observe potentially contributing to a large population by the end of summer was that crops appeared to stay suitable and were certainly in the landscape for longer than they might in other seasons. So things like forage sorghum, you know, are still standing there in paddocks where they've been cut, but now I guess the typical practice is that they just stand there until they get frosted, and then that's the end of that. But in this intervening period, whilst they might be grazed or they might just be standing there, they are providing a host for fall armyworm that's continuing to cycle through. For most regions, it's been a pretty warm March, April, which means that there's been little constraint to the fall armyworm development, but I'll talk more about the influence of temperature on fall armyworm in a bit. And I think also just the planting windows, you know, putting winter cereals in mid-February when the fall armyworm populations were really peaking has really put those crops sort of in the firing line of fall armyworm. The other thing that's, I guess, you know, anecdotal observations of agronomists that are being communicated to me is that agronomy is playing a big part in terms of the resilience of these winter cereal crops. Things like nutrition, seed quality, uniformity of the crop, I guess in some areas moisture potentially as well, means that the ability of those crops to establish rapidly, which protects them from early damage, you know, major damage from fall armyworm, plus their ability to recover from the initial damage can be compromised if the agronomy is not right. So that seems to be a pretty common theme in terms of, you know, across the growing regions, which crops are badly impacted and which aren't. It's not always about attractiveness. Sometimes it's about the plant response, or largely it's about the plant response to the damage that they incur. So just to give you a bit of a sense of what it is, you know, sort of in the worst cases where we're seeing fall armyworm impacts on oats in particular, this is the sort of thing that you'll see. And I guess I show you these pictures because I really want to sort of hammer home factoring fall armyworm in as something that might be contributing to poor establishment, poor growth and plant death, because I don't think it's front of mind for a lot of people, and it can be a bit tricky to determine what the causal factor is if you're not aware that fall armyworm might be one of those. So as I mentioned before, you can see here on the left hand side the dead seedlings in the row, and that's one of the things that we did not see in a big way in the summer crops. We know that you can get plant death, but just the vulnerability of these very small winter cereal seedlings has meant that they are dying at a much higher rate than we had seen in summer crops. So some of the things I'm going to talk about from here in terms of monitoring and the impact and so on, really I thought it would be useful just to sort of go over some of the basics, just really two basics really. One is the life cycle of fall armyworm that hopefully will help you to make sense of some of the things that come next. So just in terms of the life cycle, eggs are laid on the plant by the moths in clusters. The larvae then, when they hatch in a couple of days or maybe a little bit longer depending on temperature, will disperse through the plant either by walking, or they can let themselves down on silks and they can be blown you know, short distances or some distances. And that distribution, that dispersal, is really the basis for the hotspots that you might be familiar with. Those larvae feed on the plant, grow. Once they've reached their sort of maximum size and finished their development, they leave the plant, go down into the soil, pupate, and fall armyworm, a little bit lazier than say Helicoverpa, tend not to go quite as deep, and then they develop and a moth emerges from that point. So that's basically how fall armyworm works. The other really important thing with fall armyworm is just the rate at which they cause damage and how that relates to the size of the larvae. And so this graphic here shows you that the majority of the damage, the feeding that fall armyworm do, is in the last instar, so the 6th instar. You can see here just a sort of graphical representation of the rate at which the damage or the leaf loss occurs. So the important thing to note about this is that when you see damage start to accelerate in the crop, it's because you've got these bigger larvae. Fall armyworm don't appear and destroy crops overnight or in a period of 2 to 3 days. They are there for some time before that starts to happen, and the cooler it is, the longer they're there. So I think that's really critical as we move on to how would you know if you have a problem with fall armyworm, and at what point would you intervene? I think if you were going to intervene, this is the point at which you would intervene, at the point where you know that you've got an established population between 4th and 5th, but you haven't started to see the level of damage accelerate. Mortality, so natural mortality, things that kill fall armyworm, can have an enormous effect on these early instars from 1st through to 3rd. Something like 90% of first instar larvae do not make it to 6th. So I guess I just caution against rushing in to try and treat an infestation if what all you have is the initial infestation of very small larvae, because the likelihood of them dying from things like wind, rain, predators, disease, etc., is very high. So you've got a cereal crop. You want to know if you've got an issue with fall armyworm. How do you go about looking? Eggs have been extremely difficult to find, and Tom McCormick out at Dalby is probably about the only person I know who's actually captured a photograph of fall armyworm eggs in oats. They lay them on the leaves, as I said before, and I talked about the life cycle. But it's not essential to know whether there are eggs there. Once the eggs hatch, you get these larvae that, as I mentioned, start to distribute themselves. So you may or may not see those stages, but what you definitely can see if you have an infestation is the signs that those larvae are there and that they are starting to feed on the plant. One of the first things you might see is these windows in the leaves where the small larvae have scratched away with their mouth parts on the surface of the leaf, not all the way through, which leaves these little windows. But it is absolutely critical that you don't just look at that damage in order to make a decision, because that damage could have occurred and then the larvae have died. And you know, if you're making decisions about the need for control just on damage, you're not getting all the information that you need, which is, have we got larvae there? Are they alive and healthy? Are they, how are they progressing in terms of their size? And how soon might I start to see major damage? And will that be an impact on the crop? You know, because there's quite a big difference between having small larvae in a crop with a lot of biomass and having big larvae in a small crop that's very vulnerable. So unfurling those leaves, looking for small larvae, and then a slightly bigger one there, absolutely critical. I've mentioned a few times just how vulnerable these winter cereal seedlings are, and this is sort of a row. You can see there's a large larva here. It is possible, particularly when I took these photographs, it was very wet. So even though a lot of these plants were damaged, I couldn't see that they were wilting. But I've taken these photographs from summer crops where that's not an unusual observation when you have a crop that has large larvae in it at this early stage, is that the larvae will move to the ground during the day, particularly these 5th and 6th instar larvae. They feed on the stem and you can see plants wilting. So that's a sign, an indication that there's something wrong. Could be a disease, a root rot or something like that. But put your finger in around the base of the plant, scratch around in the soil, and in this case there was a large larva and that was responsible for that plant death. If none of those things work, I guess, or if you're seeing damage to the plant, substantial damage to the crop, but you can't find larvae, then it's important to remember that especially the large larvae may not be in the crop during the day. Large larvae can be active during the day if it's overcast, and that was the case when I took this photograph here on the left-hand side. But at night, it's more likely that those large damaging larvae will move from the soil onto the plants. And I guess it's an opportunity to check the crop just after dark to see if you can find the larvae that have been difficult to find during the day. And certainly this was the case in the sorghum crop out at Dalby, where we could see damage to the heads, but we couldn't see enough larvae to sort of really be responsible for the level of damage that was being seen during the day. But come back at night and the heads were covered in larvae that had come up off the crop. So if you're really struggling to determine whether it is fall armyworm, there's another option. How many is too many? How do you know if you're going to suffer severe loss? Well, I guess there's no Australian data at this point for winter cereals or for hay crops for that matter. So I guess we can be guided just by the overseas experience. And there's a bit of consistency across the US in terms of the thresholds that they propose. And you can see here that they're relatively low. I would add to that, I've just talked about how those small larvae, and I think here they do actually say, 12 mil or so larvae, that accounts for the mortality that's likely to occur, so that you're really counting the ones that are going to cause crop loss, not the ones that might disappear anyway. And I guess in established crops, grazing or cutting might be an option rather than spraying. How to sample in a pasture? I guess there are recommendations in the States to use something like a sweep net, which would give you an idea of whether they're there and how big they are. Probably big larvae are much more easily dislodged than small larvae, so it may be a matter of the good old-fashioned down on your hands and knees looking for fall armyworm. I've mentioned already that there's a difference between the potential impact of fall armyworm on a crop with a lot of biomass versus seedlings. Absolutely, a seedling, an establishing crop, is the most vulnerable. It's worth familiarising yourself with just how big those larvae are, what their damage potential is, because making a decision about whether you're likely to incur significant loss is a combination of not only the vulnerability of the crop, the size of the larvae, and the number of larvae. So all those factors, and this handy, you can, I don't know if these are readily accessible, you can certainly download one from the AgBiotech website, a chart that just sort of gives you a sense, if you're unfamiliar with fall armyworm, how big is the larva that you've found, where does it fit in terms of development. So I think there are some real, there are some specific issues for the fodder and grazing industries. And the first I've mentioned already is the general lack of awareness of the risk that fall armyworm poses to crops. There's an urgent need for effective options to manage these infestations, because currently there are no effective options registered or under permit for oats, barley or pasture. And one of the things I think that hasn't really been considered is the guidelines around insecticide use and residue risks. So where in the absence of permitted or registered options, clearly there will be people attempting to use things that are off-label, and there are risks in these grazing industries, and particularly, I guess dairy and meat, that there may be residue issues. So in my opinion, I think that biological control options for the grazing industries are highly desirable. Things like viruses and fungi and perhaps pheromones that prevent moths from laying in the crops are highly desirable options, because they do not have any residue issues. But these are things, I guess, for industries to consider as we go forward. When it comes to use of some of these biologicals, we have not done, I'm not aware of anyone who's done any work with the virus products that are available under permit for the use in cereal grains, fodder, forage, oilseeds, pulses, cotton, sweet corn and vegetables. Spotivir and Forlagen are the two that are available to us. We have had, and I guess I looked around to see what data there was available, and this is what I found from the US, which essentially says that over time, once you've treated, you see a decline in the population, but it doesn't differ from the sort of decline that you see in the areas that haven't been treated. And this mirrors very much the experience that we've had with these products in sorghum, vegetative sorghum and maize. So I guess under high pressure, and also with the suggestion that I'm making that the mortality factors might mean that the high mortality of small larvae means that you don't need to rush in to control that population. I guess, you know, the question is still open about the value of these products or where they might fit in terms of the management of fall armyworm. But, you know, if you're inclined to use them, they're definitely two of the options that there are permits for in these crops where there aren't options. While we're talking about insecticides, and I guess, you know, it's important to understand that fall armyworm arrived in Australia with resistance already established in the populations. Since 2020, Lisa Bird at New South Wales DPI has been doing resistance screening of populations from across Australia. At this point, we have not seen any change in the susceptibility of fall armyworm to this group of chemicals at the bottom. So these are essentially the mainstay of fall armyworm management in summer crops and vegetables. But these are probably, you know, the products that people might try to target fall armyworm with, things like synthetic pyrethroids, carbamates, and organophosphates. In terms of synthetic pyrethroids, they are likely to be the least effective, and the testing work that Lisa has done suggests that at best, you might see 10% control, which, you know, is sort of well below an economically acceptable level. With the carbamates and the organophosphates, 60 to 70 if you targeted small larvae, less on large larvae. So again, you know, not desirable options, highly disruptive, and again, not available, not legally available for the management of fall armyworm. When it comes to summer crops in maize, there are two new registrations, Vaego, which is another group 28, along with Bantacore, and then Success Neo that's been available has been replaced by Intrepid Edge for maize, not for other crops. Well, not for sorghum at this point. So there's also registration pending for a seed treatment, which will combine a group 28 and a neonicotinoid. It's a Syngenta product, still in the review process, but, you know, potentially the efficacy of this product may have a fit in these grazing industries where the susceptibility of the seedlings, particularly in late summer when they encounter high fall armyworm pressure, may be of value. In terms of the efficacy of these insecticides, I just use this. We've done a lot of efficacy work, and essentially this is a good representation of how those trials, I guess the results of those trials typically falls in this pattern. And what it says is, you know, here's the untreated control. The blue line is indoxacarb or Steward, much less efficacious than the other products, Bantacore, Affirm, and I guess it would be Success Neo for this work. We've done some work with Intrepid Edge, and it performs very similarly, so I think we can just substitute it. But the important thing to note is that in terms of knockdown, the sort of control that you see in the first, you know, sort of 3 to 5 days is almost identical for all those products. So there's absolutely almost nothing between them. The residual efficacy is where we start to see differences in terms of their contribution to fall armyworm control. And of those products, the Spinetoram products, so Intrepid Edge for broadacre, Success Neo for horticulture, has the longest residual, out to 14 days quite comfortably. And the value of the residual is really in controlling the larvae that hatch from eggs that are laid over that period. So it stops the population from continuing to build up in that crop, gives the crop time to get away and build biomass and resources in the event that it might be defoliated again further down the track. So the other thing I just wanted to note is with these products, because the residual is so is good and persistent in the plant or on the plant, it's not necessary to try and get it on when the larvae are active in the crop. So where you might have large larvae that are on the ground during the day and up on the crop at night, for example, you don't have to get it there when they're on the crop. They will come into contact with it either by feeding or moving across the foliage over the next, you know, sort of I guess, next 10 days, 7 to 10 days. You also need to be aware that if you haven't used these products previously, that it takes some time for the maximum impact of those insecticides to accumulate in the population. A firm emamectin benzoate, for example, larvae will lie about in the crop or on the ground, moribund, sort of almost zombie-like for a number of days sometimes before they disappear and sort of completely die. So the fact that you might still have larvae that are not particularly active, that you might not see them all fall on the ground in the first few days, doesn't mean that those products haven't been effective. But what you will see is probably the crop responding in terms of putting out undamaged leaves because the feeding pressure has been relieved. So spray when conditions are suitable, use the adjuvants and water volumes as per the label, and I guess also the droplet size that's recommended. And in some instances, banding, 50% bands, for example, are a way to reduce the cost per hectare of treating fall armyworm. When it comes to winter cereals, there is one permit available for wheat, and it's for emamectin benzoate, a firm, or Warlock is the generic. There are some cautions that I've highlighted here around a cutoff for application at flagleaf. Also withholding periods for grazing. So I just wanted to highlight those. The permits are all available on the APVMA website. One of the big issues, I guess, as we go into winter, or as we go into autumn and then winter, is what will be the impact of declining temperatures on fall armyworm? And I guess everyone's hoping that at the first frost they'll all freeze and fall off the crops, but unfortunately that is unlikely to be the case. And I've pulled together some information here just to give you a picture of what we might be able to expect. So this is really one of our first experiences of large populations of fall armyworm going into autumn and winter. So it's an opportunity for us to get a good sense of what happens in our local areas. But what I've done is run the Darabug fall armyworm development model to give you a sense of the change in the rate of development as we get into winter. So if we start in the north with Eyre and then central Queensland with Emerald, you can see that there's not a tremendous change as we go through the year. But if we compare sort of the peak of fall armyworm here in February, it's taking, sort of 12, well, if you just look at the orange bar, for example, to get through that most damaging stage of 4th instar larva to 6th instar larva, about 10 days. By the time we get into May and June, that's extended quite dramatically, so 3 to 4 times longer to do that. When we get in somewhere like Dalby and then down into the mid-north coast of New South Wales, you can see the same sort of trend, a dramatic lengthening of the time that those larvae are there in the crop. Eggs and larvae are there in the crop, and a much greater length of time required to get pupae through to mock emergence. So I think that's an important thing. The longer larvae are in a crop, eggs and larvae in a crop, the more likely it is that they'll suffer some mortality factor and not make it to those damaging later instars. I might just skip over that one. But so what else does temperature do that's sort of benefit in terms of suppressing fall armyworm activity and potential impact? So moths, if we look at oviposition, so cumulative egg production of a female moth, what we can see is when the average temperature declines, the egg production drops off quite dramatically. So if we have moths still coming out of sorghum stubbles or late maize crops or millet and so on, the likelihood that they will continue to produce eggs at the peak rate at a sort of average of 25 degrees is dramatically reduced. So that's a positive. I guess as we go into winter, we'll see fewer of these high density infestations in winter cereals. We might still see some fall armyworm, but not at the sort of intensity that is causing the damage that we're seeing currently. If you're hoping that a frost will kill them, these are the sort of data that suggest that that's not going to happen. So this is a trial from the US where Different life stages were exposed for 3 hours to low temperatures. And what's really striking is that, it's something like, say, a moderate, a reasonable frost -5, we're still getting good levels of survival of all life stages. So it's not until you get to extremely low temperatures that you start to see mortality across the board. So there's also a study a recent study in China that found that it's 7 degrees average temperature, which is very cold. It still took more than 30 days for late instar larvae to completely disappear from crops. So it's going to be a matter of sort of steady attrition of the population, not a sudden sort of on-off as a result of cold temperatures. And for the question, I guess there are a lot of questions about what will this high summer and autumn into winter population of fall armyworm mean for the likelihood of higher pressure early next season? Well, if we look at this little set of data from the US, again, looking at the survival of pupae and the success of moths emerging from pupae held at different temperatures, you can see low temperatures have a really big impact, that the mortality, the longer they're at that temperature, so at 10 days, very little survival of moths from pupae held at these low temperatures. Where the temperature fluctuates, which is probably more our situation through winter, soil temperatures, and probably quite a bit higher than this, the mortality still increases the longer that they're sitting there in cold or cool soil, but it's sort of it's likely that pupae will survive and moths will emerge at some temperatures. So yeah, I guess it's a little bit unknown. I would be really encouraging of people who are thinking about planting winter cereals, planting things like maize early, that if you have had late crops or you've had winter cereals, to look for pupae in those crops to give you a sense of what that carryover population might be. And certainly that's the sort of thing that we'll be doing over winter, to try and get a sense of what's going on across some of the cropping regions. So just a couple of other things. If you're growing winter cereals and you have fall armyworm populations that impact them, there are a couple of other things that I just wanted to highlight. One is that, when you've got a bit of biomass, the crop's established, they can tolerate, particularly the forage crops can tolerate defoliation. They're designed to recover from grazing. So it's not that, the risk reduces quite considerably. If at all feasible, delaying the planting of susceptible crops, particularly where they've been in regions where there's been high fall armyworm pressure, may contribute to a reduction in the risk of significant loss. Now, I guess one of the things that we are seeing is crops being re-sown after they've experienced quite severe fall armyworm damage. And when probably by the time that you have bare patches that you want to re-sow, you also have large larvae like these. So this is the crop where, there was almost nothing left, large larvae making their way across those paddocks looking for something else to eat. So it's important that you look to see whether you still have a population of fall armyworm, and particularly these large, very damaging fall armyworm in the paddock before you put the crop back in. The other thing just to think about is, these larvae were heading somewhere. In this paddock, they were stopping in the headland where there were grasses and feeding on those grasses. And they will do the same thing walking out of a paddock that's been badly damaged and there's little to feed on, into neighbouring crops. So keep an eye on neighbouring crops because those larvae do have the capacity to walk quite some distance to find things to eat. And there have been a few questions about biological control at the time you registered. And I guess the really positive thing is that there is an abundance of things that are able to attack and kill fall armyworm, from things like the parasitoid, Trichogramma parasitoids and Telenomas parasitoids of the eggs, and Chilonas. Probably one of the most abundant things that we see in our trials is this little egg larval parasitoid. And tachinid flies love large larvae. Don't don't prevent the damage from occurring, but make a valuable contribution to population suppression. In warmer, wetter areas, you might see Metarhizium riley. We see it towards the end of the season in southern Queensland when the populations get going. And then there are some native MPVs that we've been seeing towards the end of the season. But readily recognisable predators that you'd be familiar with, things like spiders, lady beetles, pirate bugs and so on, are all very active on fall armyworm, and the predatory shield bugs that seem to be quite attuned to turning up when there are lots of fall armyworm. So just to finish off, I guess this is, a sort of summary of where we have seen fall armyworm. On the left-hand side, those crops in which we have seen major impact. And then there's a suite of crops where we have had records of damage, but it's a little unclear as to whether they were things that, infestations that were, I guess, unusual, or whether they had been facilitated by the proximity to a maize crop or a forage sorghum or something like that. But time will tell whether, these things move over to this list. But at this point, this is the list, a relatively short list of crops that we are seeing major impacts of fall armyworm. And just to finish up, just some acknowledgements there to the Queensland Government for their investment, and also to the growers and agronomists who've been really generous in sharing their experiences. That's helped us to, to understand what's going on and to communicate that more broadly. And because lots of fall armyworm is never enough, if you want even more, and I think, a much broader perspective than the one that I've given you. So a number of researchers, growers, agronomists and so on talking to Landline on Sunday. You can join that and see what other people are doing around the place in terms of fall armyworm. So thank you, Greg.